Hey, hello there. Sorry that I'm not there in person. This is the best I can do, so you can at least hear me describe what's going on instead of just looking like you would have done yesterday. For the do now, if you're not yet ready, I say pause the video and then start the video when you're ready to look at the answers very quickly. Okay, for the perimeter. Well, with the rectangle, pretty straightforward, right? I can figure out each length of each side. We add up those lengths. It does a perimeter of 30. Rectangle is also pretty straightforward for the area. 5 times 10 gets us 50, and that is the area. Triangle is going to be a little bit slower because we've got a vertical side that has an obvious length of 9, a horizontal side with an obvious length of 12, but then we have that diagonal side, the hypotenuse. And so I'll have to do a squared plus b squared equals c squared to figure out the missing value. So for A, I'll do 9 times 9. For B, I'll do 12 times 12, right? 9 squared plus 12 squared. 9 times 9, of course, is 81. 12 times 12, 144. And because we're looking for the hypotenuse, right? We're looking for the longest side, we end up adding those numbers together. Of course, if 225 seems extremely too big, that's because we've not yet done the last step. We need to take the square root, right? We need to go backward. We've done this one so many times that maybe you're starting to memorize that it's 15. Or if you've not memorized that and you want to make a guess, you say, hey, 10 times 10 is 100. That's too small. 20 times 20 is 400. That's too big. So you know it's between 10 and 20, and you also know the answer needs to end with the 5, so your guess is 15. Now that we have the lengths of all three sides, for the perimeter, we just add those lengths together. We get 36 for the perimeter. Area. Well, if I just did 12 times 9, I'd get the area of a rectangle. But of course, the triangle only takes up half of that area. So I need 1/2 times 12 times 9. And so that will give us 6 times 9, which is 54. That is the area of the triangle. Learning target for today. Simplify radicals, and we'll still be looking at the three sides of a right triangle and the perimeter of polygons. If you remembered yesterday, we were working with finding the missing side of a right triangle, and we discovered sometimes we ended up with a square root that we could not do anything with. And so today I want to talk about how we can sometimes simplify them a little bit. Right, so on the back side of the paper that had your do now, you got space for 10 questions. Please follow along. Pause the video if need be, if I start going a little bit too fast. So let's simplify each expression. So for number 1, please copy down 7 squared. And then, of course, that means I have to do 7 times 7. That answer is 49. For number 2, please copy down the square root of 64. Remember, with square root, we're going the opposite direction now. So I'm trying to think what number times itself makes 64. Well, that's got to be 8, right? 8 times 8 makes 64. Next to your number 3, please copy down 10 squared, right? Also known as 10 to the second power. And of course, the answer here, well, it's going to be 10 times 10, which gets us a value of 100. Square root of 25 is your fourth example. Again, I got to think what times what makes 25. And so, well, it'll be 5 times 5. Right? 5 times 5 makes 25. So the answer is just 5. Okay, now for number 5, we get a really interesting one. Square root of 18. Right? I can't think of a number that works perfectly. Right? 4 times 4 is 16. That's a little bit too small. 5 times 5 is 25. That's a little bit too big. So instead, I want to try to simplify this a little bit. So I need to think of two numbers that multiply to be 18. And I'm going to choose 9 times 2. Notice both the 9 and the 2 are still inside square root symbols. Right? Square root of 9 times square root of 2 has the same value as square root of 18. But you should be able to recognize that, hey, square root of 9, that's plain old 3. So I can rewrite this as 3 times the square root of 2. Now, if you're wondering why I chose 9 times 2 instead of 6 times 3, well, if I'd done 6 times 3, I can't take the square root of 6. I can't take the square root of 3. Right? I have to be able to take the square root of one of those numbers. That's why I chose 9 times 2 for 18. And that answer is as simplified as we can make it. For number 6, we want to take a look at square root of 7. So, let me see. I can't do square root of 7, so I'm going to try to think of two numbers that multiply to be 7. And, the only thing I can think of is 1 times 7, because 7 is a prime number. So, since 7 is a prime number, I can't simplify it. The answer will just be square root of 7. Right? Because 7 is a prime number. Can't do anything with it. So that answer is just square root of 7. Next section, we're going to determine if the three sides given form a right triangle. Right? So for question number 7, please copy down 4, 7, and 10. Now, this is a previously learned skill, so if you want to challenge to yourself and try work ahead of me and get an answer before I get it, be my guest. You can even stop the video if you really want to do that. If you want to follow along, however, I know I have to do 4 squared plus 7 squared, right? I take the two smaller sides. 4 times 4 is 16. 7 times 7 is 49. That adds up to 65. Then I take the longest side, right? If it's a right triangle, that longest side would be the hypotenuse. I got to figure out, well, what is the value of 10 squared? 10 times 10 is 100. Now, the question said determine. That means we've got to say yes or no. Well, 100 and 65 are not the same, so no. Those three numbers would not form a right triangle. Number 8, please copy down 20, 21, and 29. Again, if you want to challenge yourselves and try to get the answer on your own, go ahead and pause the video. Okay, here we go. I'm going to take the two smaller sides, and I'll do 20 squared plus 21 squared. Now, 20 times 20, you should actually be able to do this one in your head, right? 2 times 2 is 4, but then I got to put a couple zeros on there. 21 times 21 is a little bit trickier. You're probably not going to want to do that in your head. You probably don't have it memorized. So pencil and paper could be your friend, or this might be an okay time to go for a calculator assist. And then if I add those two values together, I get 841. Well, what's 29 squared? Again, you can work this out with pencil and paper, or if you want to try use a calculator for an assist. But that has a value of 841. Hey, those match. So yes, those three numbers could be the sides of a right triangle. All right, the shorter sides, the legs, would be 20 and 21. The long side, the hypotenuse, would be 29. Again, that's a skill we've already worked on. Same thing with questions 9 and 10. It's a skill that we've already worked on. All right, so for number 9, if we know that side A has a value of 6, side B has a value of 8, we want to figure out the value of side C. Again, if you want to challenge yourselves, you can pause the video. Okay, I would say we gotta start with a squared plus b squared equals c squared. Plug in the values I know. I know a is 6, I know b is 8. I'm trying to figure out the value of c. 6 times 6 is 36. 8 times 8 is 64. Add those two values together, you get 100. Now, if you're thinking 100 seems like a really big number compared to 6 and 8, remember we haven't done the last step yet. We don't want c squared, we just want c. So I got to ask myself, well, what number times itself makes 100? Well, that'd be 10, right? 10 times 10 makes 100. So the value of c would be 10. At any point, if I'm just going too fast, go ahead and hit the pause button or rewind it. Number 10. Well, we know side A is 5. We're looking for side B. And we know side C is 13. Stop the video if you want to try to do it on your own. Okay, so here we go. Right, a squared plus b squared is c squared. I know a has to be 5. I know c has to be 13. Five times 5, of course, is 25. 13 times 13, you probably don't have memorized. You might want to grab a calculator or use scratch paper. 13 times 13 is 169. Now, instead of adding those numbers together, I'm going to subtract because I'm actually looking for one of the shorter sides, right? I'm not looking for the hypotenuse. The hypotenuse is 13. That's the big side. So instead, I actually need to subtract. I need to do 169 minus 25. That gets us a value of 144. Take the square root of 144. Again, hopefully sometime in elementary school you memorize your multiplication table up to the 12s. And so you should have this one memorized. 12 times 12 makes 144. And so B equals 12. At this juncture, it's time to do some independent work. But I will be rejoining you in a while. But it's time for a second worksheet. You can work independently. You can pause or stop the video at this point. Turn it back on when ready. Okay, are we ready to continue? Now, if you didn't finish all of the second worksheet, you can also take it home for homework, but I'm hoping that most of you made a lot of progress through that. And so we want to take a look at the perimeter of the polygon here. I'm going to work through question number 1 with you. So this is worksheet number 3, right? And I'm going to work through this first one with you. and then leave you with independent practice on the rest of them. Well, for perimeter, I need all the exterior edges. Well, up on top, that one's obviously 4 units in length. Bottom left, that piece is 6 units in length. Bottom right, I've got a piece that is 15 in length. And then there's one more straight edge that's vertical that has a length of 3. Now, there are 3 diagonal sides. And I got to figure those out. Now, notice I put that 4 in red because that's actually not one of the numbers I'm going to use as the perimeter. But I need to use that in an aid to try to figure out the hypotenuse of that small triangle I just cut off there. Right? So I got to do my a squared plus b squared is c squared. So I got to do 3 squared plus 4 squared equals c squared. 3 times 3, of course, is 9. 4 times 4 is 16. Again, if I'm going too fast, go ahead and hit the pause button. 9 plus 16 is 25. Last step, got to take the square root of 25. And that's 5. After a while, you're going to actually start memorizing some of these. You're like, hey, how many times have we come up with that 3, 4, 5 triangle? Right, so 5 we're going to use. Well, let's figure out another one of the diagonals. If I picture here, I say, hey, I got a height of 8, length of 15. Let's figure out that missing side. I'm going to plug in 8. I'm going to plug in 15. 8 times 8 is 64. That you should know. 15 times 15. We've done this so often you might start to remember that it's 225. If not, pencil and paper could be your friend. Or a handheld calculator can be your friend. Add those together. Now, what you're probably not going to go around memorizing is the square root of 289. And we don't have a really good clue because it ends with a 9, but it's like, well, 3 times 3 could make that 9. But 7 times 7 makes 49. That could also make that 9. And so we don't have a real obvious choice. And so this is when your best friend just might be a calculator. Turns out it's 17. Right? But if you guess 23, that wouldn't be a bad guess, right? Because you know it has to end with a 9. If you guess 13, that's not the best guess because the hypotenuse has to be the longest side. So you have to guess something larger than 15, right? Because one of the sides was 15. So you got to guess something larger than 15. So again, if you guess 23, that's not a bad guess, but it's actually 17. We got one more side we got to figure out. Again, I got to cut this off into a triangle. We got a 6. We got an 8. We've done this one a few times too. You might start to get this one memorized. Right? 6 times 6 is 36. 8 times 8 is 64. Those two numbers add up to be 100. Square root of 100 is 10. Now I know all of the exterior lengths. So for the perimeter, I just need to find the sum of those distances. One method is just to do a big vertical column. Some of you instead might want to chunk them. Say, hey, I'm going to take the 17 and the 3. That makes a 20. Hey, the 15 and 5. That makes a 20. The 6 and the 4 makes a 10. And you can chunk them together and get an answer that way. I just decided to add the whole thing up, and surprise, it's 60. All right, but if you chunk them, you could have had 20 plus 20 plus 10 plus 10. That, of course, makes 60. Okay, you've got a couple more questions to do, and I'm leaving that as independent practice. Thanks for following along. I hope you found this to be very productive.